Looking at molarity one last time, we're going to do some practice problems just to make sure we got an understanding of how to do molarity calculations and solve for the unknown variables. Molarity is going to be the moles per liter volume. So our formula is going to be molarity equals moles over volume. Moles has to be measured in moles, volume has to be measured in liters, and molarity will be measured in molar or moles per liter. So with that said, let's just jump straight into these problems and see what we can figure out. The first thing you want to do is pick out any given information, and from there you can plug into your formula. So our first problem says, what is the molarity of a solution made by dissolving 50 grams of sodium chloride in enough water to make 75 milliliters of solution? So it says, what is the molarity? So I'm looking for how molar or how concentrated this solution is. It's made by dissolving 50 grams of sodium chloride in water. So I have a mass, and that is 50 grams of sodium chloride. And we know we can't do anything with a mass. We always have to convert that to moles. And we have 75 milliliters of solution. So our volume is 75 milliliters. We also know our volume has to be in liters. So 75 milliliters is 0.075 liters. And I know that because I moved my decimal 3 times to the left. All right, next we got to take care of this mole conversion. So I got 50 grams. I got 50 grams of NaCl. Put that over 1. I have grams. I want moles. So 1 mole of NaCl is equal to 58 grams of NaCl. I got 58 by adding the atomic mass numbers of sodium and chlorine, and I did round to the nearest whole number. Chlorine's 35, sodium is 23. Add those together, you get 58. So that'll cancel out grams of sodium chloride. Now just go to my calculator, do a little bit of math. So I got 50 times 1 divided by 58. And we get 0.86, 0.86. That's going to be my moles. Now that we got that information, we can figure out the molarity. So molarity is equal to moles divided by volume. Molarity is going to be X. N is our moles, that's 0.86. V is our volume, that's 0.075. Now all we got to do is divide. So 0.86 divided by 0.075, and we get 11.5. And I did round that number up. So 11.5. We need a unit here. So 11.5 what? We're looking at molarity and concentration. So I can either put molar with a capital M, or I can also do moles per liter. It's really your choice. I personally prefer moles per liter. It just looks cleaner to me. It looks better to me. So there is that answer. Alright, let's look at another one. So as always, let's pick out our given information to see what we can do. So what mass of potassium nitrate? So I'm looking for a mass. Now our formula does not give us mass, but we do get moles from our formula. So what we're going to have to do is solve for moles and do a mole conversion to mass. So what mass is needed to make 1.5 liters of a 0.4 molar solution? So I got a volume of 1.5 liters and a concentration or molarity of 0.4 molar. Alright, my molarity is in molarity, that's good. My volume is in liters, that's good. I need to find moles in order to find grams. So molarity equals moles over volume. My molarity is 0.4. Moles is X. Volume is 1.5. To do this mathematically, I'm going to stick 0.4 over 1, cross multiply. 1 times X is 1X. 0.4 times 1.5 gives me 0.6. I divide by the value with X. Ones cancel. X equals 0.6. And that's going to be moles. But we're not looking for moles. We're looking for mass. So if I got 0.6 moles of KNO3, how many grams is that? So let's stick that over 1. I need to change moles to grams. So 1 mole of KNO3 is how many grams? Well, oxygen, 16 grams, and there's 3 of them, so that's 48 grams. Plus 14 for nitrogen, plus 39 for potassium. So 1 mole is 101 grams of KNO3. So moles of KNO3 cancel. Now we can just solve out our easy math. 0.6 times 101 tells me we're going to need a mass of 60.6 grams KNO3. There is that answer. Alright, so next problem. It says what volume in milliliters of a 20 molar sulfuric acid solution is needed to contain 3.15 grams of sulfuric acid? So it says what volume. So we're looking for volume and it wants it in milliliters. Remember, our formula solves for liters. So when we find our volume, we'll have to convert it. We got a 20 molar solution, so molarity has a concentration of 20 molar. And we want it to contain 3.5 grams of H2SO4. So I have a mass of 3.15 grams. Problem is, my formula doesn't use mass. So I also got to do a conversion there. So let's do our mole conversion first. So I got 3.15 grams of sulfuric acid. And I need to know how many moles is that. So 1 mole of H2SO4 is 98 grams. And I know that because I add up my atomic masses. Sulfur's 32, 4 oxygens is 64, plus 2 hydrogens should be 98 grams. So grams of H2SO4 cancels out, leaves me with moles. So 3.15 times 1 divided by 98 gives me 0.032 moles H2SO4. Alright, now we got moles and we got molarity. We can figure out our volume. So molarity equals moles over volume. Our molarity is 20. Our moles is 0.032. And our volume is X. We'll stick 20 over 1, cross multiply. 1 times 0.032 is 0.032. 20 times X is 20X. I divide by the value with X, that cancels. Divide by 20. X equals 0.002. And this is liters, but we want our answer in milliliters. So to convert milliliters to liters, I'm going to move this decimal 3 times to the right. So this is really going to be 2 milliliters of H2SO4. There's that answer. Let's look at another one. So what is the molarity of a solution containing 22 grams of sodium hydroxide in 550 milliliters of solution? Pretty straightforward for the most part. So we're looking for molarity. We got a solution containing 22 grams. So I got a mass. That is sodium hydroxide in a volume of 550 milliliters. I need this to be liters, so I make that quick conversion. That's going to be 0.55 liters. I did that just by moving this decimal 3 times to the left. So as always, we got to do this mole conversion. So let's do that right quick. So I got 22 grams NaOH. I need that to be moles. So 1 mole NaOH is how many grams? Well, let's look at our periodic table. Sodium is 23, oxygen 16, hydrogen is 1. We add those up, we get 40. So NaOH is 40 grams per mole. Grams NaOH cancel. So 22 times 1 divided by 40 gives me 0.55 moles of sodium hydroxide. Now we got moles. Now we got volume. We can find molarity because molarity is equal to moles divided by volume. Molarity is X. Moles is 0.55. My volume is also 0.55. So our molarity is 1 mole per liter. There is that answer. All right, let's look at one last problem. So how many grams of calcium hydroxide are needed to make 200 milliliters of a 0.3 molar solution? So I'm looking for grams. So I'm looking for a mass of calcium hydroxide. Since my formula doesn't give mass, but instead gives moles, I need to figure out moles so I can convert to mass. I have a volume of 200 milliliters, and as we know, we got to convert that to liters, so that's 0.2 liters. Again, I just moved this decimal 3 times to the left. And I have a molarity or concentration of 0.3 molar. So molarity equals moles over volume. Molarity is 0.3. Moles is what I'm looking for. My volume is 0.2. So I put 0.3 over 1, cross multiply. So 1 times x is 1x. 0.3 times 0.2 is 0.06. I divide by the value with x. 1 cancels. X equals 0.06. That's 0.06 moles. But I don't need moles. I need grams. So let's do that quick conversion. So we got moles of calcium hydroxide, 0.06 moles of calcium hydroxide, and I need to change that to grams. So that goes over 1. So 1 mole calcium hydroxide is how many grams? Oh, calcium is 40, 2 oxygens is 32, 2 hydrogens is 2 together, that makes 74. So 74 grams per mole for calcium hydroxide. Moles of calcium hydroxide cancel. So 0.06 times 74 gives me 4.44 grams of calcium hydroxide. And there's that answer. So molarity is not too difficult. It's just a matter of picking out your units, making sure they're in the correct form, and then plugging into a formula to solve for the unknown variable. But as always, practice those problems so you get better at it, because molarity will eventually run into some other type of problems, other lessons, and you don't want to get caught on molarity when you're trying to learn something new that uses molarity. So I hope this video helps, and as always, good luck on your tests.